So a lot of the areas that we are working on start from the simple observation that digitalization basically has led to this datafication, right? And it's quite interesting that many of you who started perhaps working on digital transformation in the past really didn't foresee that digitalization, the main impact of digitalization is actually datafication, right? The fact that if we make something digital, then that automatically means that there is a data trail that has been generated as a result, right? And so this datafication has led to a total new data ecosystem from my perspective, both in terms of volume, but also in terms, of course, of what we can do because of the veracity and the velocity, meaning we can actually monitor society in real time almost if we start leveraging that data, which was never the case before, right? Because we always had kind of reported behavior. And of course, we have a massive amount of new variety, which, by the way, explains, of course, the march of artificial intelligence, because without this kind of variety, including the availability of unstructured data, we would not have seen the advances that we currently have. Next slide. Now, the real interesting part of datification, and again, this is a data and policy fireside chat, so I'm going to go quickly here because all of this will be familiar to all of you, but I think it's important to set the stage and to actually quite often go back to basics, why all of this is actually important. Now, the key characteristics of digital data, and that is where it becomes interesting from our point of view, is that A, it's intangible. It's supposed to be easy to copy and replicate, right? Meaning because it's digital, you don't really have to do any kind of manual labor or manual copying in order to actually have a copy of the data that is already there. It's also non-rivalrous, right? And if I share it with you, meaning I still have my data, you have just a copy of my data, right? So it's kind of non-rivalrous as such. Of course, we can argue that that also might anyway be challenged in some conditions. And um, um, talking about kind of the typical network effect of digital artifacts is that if you, anyway, the more you use it, the more value actually you create from it. And so the real interesting element of digital data, and from my point of view, the real opportunity for society as it relates to datification is that we can actually reuse data that was collected for one purpose. We can start reusing that for other purposes, right? So we don't always have to start collecting new data because we could actually start using the data. Now, of course, many of you will say, well, it's not so straightforward because reusability is an issue. You actually need to quite often clean data, and so that's all correct. But in essence, the premise still holds true that the real potential of the data age is the fact that we can start reusing data for other purposes than initially intended. Now, obviously, there are challenges with that. Next slide. And one of the challenge, and of course, anyway, and by the way, just to document the potential, meaning Marta and myself also wrote this piece, is just to make the point that actually today's scientific enterprise, right, is totally changing as a result of datification. And my prediction is that the future Nobel Prize winners will all be probably winners that have used data in new ways, right? Whether it's for social science purposes, whether it's economics, and you can also look at even this year's prize for economics, whether it's for physics, whether it's for chemistry, or whether it's for anyway computational social science. So what we see is that actually the whole scientific enterprise is also changing as a result of actually data reuse and as a result of the fact that we can start using data for other purposes. And just look at this year's Nobel Prize that, anyway, and a few of them that would not exist without actually being able to reuse data for other purposes. Next slide. Now, one of the challenges, of course, is that in order to be able to reuse data for other purposes than initially intended, you actually need access to data. And that turns out to be one of the main challenges, right? Is that we have this asymmetry between those that need data and those that have data. And the asymmetry is both in terms of access to data, right? Because anyway, it's very hard to actually have access to data that others might have for a variety of reasons, mainly because we basically have emphasized preventing misuse, right? And so we have created a governance structure that really is very good at preventing misuse, but is very bad at providing access for reuse in a responsible way, right? And so in addition to the data asymmetry, we also have an information asymmetry, by which I mean that we actually don't know who has data quite often that could be reused for other purposes. And that both within the public sector, despite the fact that we've made advances on open government data, that's especially true in the private sector, but it's also true in the scientific sector, right? I mean, open science and open data has really not advanced in a way that we can start leveraging it for making massive progress in a scientific way as well, because much of the data still is stovepiped. And as Andrew will tell you, our effort to actually provide and publish data has not really fundamentally been a success, right? Mainly because people are still kind of hoarding their own data as well. So we have this data asymmetry that really holds us back. Next slide. Now, the additional element, of course, is that it's not just a problem of having access to the data, because in order to have data be used for society, access to data is important, because then we can start reusing it to generate insight. For instance, with regard to a crisis, we can start reusing telco data, for instance, to monitor how people are moving around. I mean, we had a special issue at Data and Policy where we focused on access to telco data during COVID-19, where we focused on, anyway, how was this really important and made a difference in understanding social distancing, in understanding how we can identify hotspots so that we don't have to close down society completely, but that we actually can focus on those areas that might be higher at risk and so on. Now, access is very important, but in order to make an impact, we actually need action based upon the insight, right? And so the first problem is the one that I just introduced, is how do we get access to data to generate insight, which we call the first mile problem of the data ecosystem. But if we want to have real impact from the data, we actually also have to look at what do then policymakers and decision makers, how do they then act upon the insight? How do they go from insight to action? And that turns out to be equally problematic, because there is a lot of insight, there's a lot of evidence, right? And anyway, just look at what Cambridge University Press is producing on a daily basis. Is this making society any better, right? And part of the challenge is that policymakers are just not using the evidence or translating the evidence in a way that actually can change the way we go about solving problems, right? And this is what we call the last mile. And so what the data tank and what, anyway, I've been spending my time on is to really try to solve the first mile, but also trying to more and more start solving the last mile. And in this context, I've written quite a lot about, anyway, how do we change the decision ecosystem to actually accommodate the new data ecosystem? How do we go and develop decision accelerator labs, which is a key topic from my point of view that every person that is working on data and evidence also should be concerned about, because we cannot just declare victory by saying now we have access to data and now we have created more insight. Because if the insight is not used to actually translate into action, then that will be problematic. Now, we've seen this. Many funders are starting, especially in the UK, many funders are starting to fund living evidence, are starting to fund really to focus on, anyway, not just creating evidence, but also translational kind of approaches as well. And this might be also, Andrew Zayab, kind of an increasingly important topic for the journal as well, and for even Data for Policy. And of course, we had a panel at the Data for Policy conference in London last July, where we focused on decision intelligence, which is actually really the kind of last mile problem. How do you go from data intelligence to decision intelligence? Now, next slide. We've written about this also in Data and Policy. A previous blog was actually focused on what have we learned with regard to the first mile challenge as it relates to the pandemic, and then the last mile challenge. And this was part of a project that I'm part of, which is called Escape, where they bring all the main modelers of Europe who were during the pandemic were basically developing all the models that were used for decision making in order to understand the spread of the of COVID-19. The key message there was we didn't have access to the data that we needed, especially granular data. But then the second key message was that once we then identified and developed insight, no one was using it. And so this was the first mile and the last mile kind of problem that we need to establish as well. So next slide. So this is kind of setting the stage for the piece. The short, more a reflection than really a fundamental analysis, but the piece that Marta, Anna, and myself wrote, because we saw the same kind of challenge and the same kind of issues in Valencia. As Marta will tell you, it was different in the sense of the first mile might be less problematic, but then the last mile was more problematic. But I think the key issue here is that they are very closely aligned, right? And that the first mile ultimately needs to anticipate the last mile, right? Because why seek access to data if you don't know how it's going to be used? And the last mile should predict what actually the access and what the data is that they need. And quite often, those that are in the last mile are separate from the first mile, and vice versa. And as a result, you have this fundamental mismatch that actually leads to harm and to what has happened also in Valencia. So with that, that was kind of enough setting the stage, perhaps a little bit too abstract, but over to you, Marta.
Thanks, Stefan. And I have just a couple of slides with some overlaps, so I'll try to synthesize as much as possible this last mile problem that Stefan just started to discuss with the slides. So you probably are aware of what happened in Valencia on the 29th of October on a Tuesday. And I start by illustrating this last mile problem by saying that if you have a look on the internet and you look out for data on the damage, on the impact of the floods, you will be flooded with data. And most of the time, this data will be not really accurate because maybe they haven't been updated. And this is an example of that, a map that reports quite accurately the impact of the disaster, but not with updated data, so that to what extent the data is accurate anymore is something we could discuss, or directly missing disinformation on social media. Like this post was largely circulated on the following next days of the after the disaster, with the false pretension that all these blue dots you see on the screen were dams that were removed from the Valencian waterways and causing the damage that we saw. In fact, these are barriers, river barriers that are still there, that are not dams. So it's again all the type of misinformation that surrounds this overflowing of data during and after the disaster that create the noise that we talk about in the post. So one of the problems in the last mile is how to sift the signal in a land in a sea of noise. That's one of the first problems. So we find this case interesting because it's not the lack of data, the first mile problem that is at stake here. Here you have what I would call an oracle. This is data from the Hydrographic Confederation of Hooker, which is the maximum water authority in that area. They have sensors, not working anymore, by the way, they've been all damaged, but they have sensors that broadcast every 5 minutes open data on the volume of water on the different waterways in Valencia. So accurate information, oracular information, I would say, because it's official, broadcasted and made open data every 5 minutes. So that's something decision makers could be tapping on when making decisions, and in fact they did. On that day, on the 29th of October, the Valencian government issued, the Department of Emergencies issued the first alert in the morning at noon at 2020, based on the data you see on the map. So there was like the attempt to translate this data into action, at least by some parts of the government in charge of the emergency. You can see as well that they how the day went. You have the volume of the main waterway that caused the flooding in Valencia. It started with a relatively a small volume, but around from 4 5 p.m., the volume started to increase dramatically. And as you can see, the other graphic shows about the same, the increasing volume by 10 times. To give you an idea, it's like a whole year worth of rain in less than 8 hours. And also, to give you another idea, it's 4 times the Thames volume when it crosses London, multiply it by 4. All that happened that evening in Valencia. So here you have uh, data feeding the decision maker channels. Not only them, but also they were posted on social media. Some organizations acted on that. Valencia University, for example, canceled all the classes in the morning. Other schools in other areas did the same. Some companies sent their workers home. Some others didn't. And here you have also how the chronology of alerts and warnings to the population that matches this increase in water volumes. And as you can see, even though there were some alerts issued by the Hydrographic Confederation of the River Júcar, the let's say the most important oracle, which was the general alert of the Valencian government to the population in danger, didn't reach that population until 8 p.m., past 8 p.m. in the evening. So when the peak of the flood was reached, too late for people in the area to react safely, and that's what basically explains not the damage that of 100 in a 100 in a century flood may cause, but definitely the number of victims that didn't have an alert on time. Also because on that day there was no rain in those areas, so the water came from upstream in a very quick and wild way. So the key point here is well, various questions that I will leave open to discussion, right? So we know very well this is kind of a global challenge, and I'm an editor in that area. And global challenges such as floods and health crisis will not be solved by an individual actor or one single dataset holder. We know that very well. So it will require a coordinated effort, coalitions, collaboratives, where governments obviously will play a key role because of the mandate they have, because of the infrastructure, the open data they can act upon, and so on and so forth. But the question is, what happens when governments or whoever is in charge does not assume the key role it's meant to assume? How, therefore, a decentralized network of other oracles, and that's how the name I usually put to accurate data from trusted sources, how a decentralized network can come to the rescue, because that may happen for different reasons. So how to make the network of agents that are involved in a disaster more resilient by being more decentralized and with more redundancies as well. So that's my question, because it remains open. as a last mile problem that we illustrated at the start, that it's part of the cycle of data reuse, how to make sure that we not only heard the right signals in the midst of the noise, but are able to act effectively and efficiently upon those signals. And the role of data steward and data stewardship, of course, should be relevant to that question, in our opinion, because there's more often than not a huge deluge of data that require these kind of humans in the loop to curate, to make sense, and to orchestrate the response that these type of events that will be more often than not increasing will demand from us. I will leave it here as questions for discussion, but obviously any comments, feedback, questions that you may have or other first-hand information will be welcome. Thank you so much.